split into left and right hand side, fx and f prime x, I think it's easier to see. Okay, the original graph that you draw, 0.1x cubed minus 2x minus 5 is a cubic curve. Okay, so that is the graph on the left hand side, this is the graph of fx. Then the graph in the middle is the graph of dy dx. Okay, so I want you to be able to see the relationship between the graph on the left and the graph on the right hand side. Okay, I have a scroll bar at the bottom is to move along the graph. Okay, first we look at the left hand side of the graph of fx. On the left hand side, you follow this blue line. On the left hand side, you find that this part of the graph, the gradient is positive. Can you see? On the left hand side, the gradient is positive. So how does that show on the graph of dy dx? You find that the graph of dy dx, now you look at the red dotted line. This part of the graph, the dy dx is positive. So that's why it's above the x-axis. That is for the left hand side of fx. Okay, now we look at the middle parts of the graph of fx. Okay, look at the blue dotted line from around minus 3 up to roughly 3. You find that this part of the graph, the gradient is negative. The blue color graph, gradient is negative. So how does that reflect on the graph of dy dx? You find that between minus 3 to 3, now you look at the red graph, the dy dx is negative. That's why the red graph between minus 3 to 3 is below the x-axis. So this is the relationship. Okay, now the last part is to look at the right hand side of the graph of fx. Starting from around x equals to 3. You find that from x equals to 3 onwards, the gradient of the blue graph is positive. Positive gradients. So how does that reflect on the graph of the dy dx? You find that from x equals 3 onwards, dy dx is above the x-axis. Okay, so that's the relationship between the graph of fx on the left and the graph of f prime x on the right hand side. Okay, so you can see this on your graphic calculator as well. Okay, so I have printed out the explanation on the red line here. Okay, graph is increasing, f prime is positive. Okay, my applet here can show further one more step. Okay, if I hide this fx, on the right side I can show the graph of f double prime x as well. Okay, you can take the graph of dy dx and differentiate again. Okay, that relates to the next part, concavity of the curve. Okay, look at the graph of dy dx now. Here on the negative x-axis, you find dy dx has a downward slope, negative gradients. So if you differentiate dy dx again, you get d2y dx squared. What happened to the graph of d2y dx squared? It's below the x-axis. For the negative part here, the gradient of the dy dx is negative. So that's why on the right side, d2y dx squared is below the x-axis. Okay, the last thing to show you is on the right hand side. Here the dy dx has positive gradients. Can you see the gradient of x positive is positive gradients. So therefore the graph of d2y dx squared is above the x-axis. If you are still not clear about this, please go home and look at the applets and key any function that you like, and then you can plot out all three graphs. Fx, f prime x, f double prime x. Okay, and make sure what you see on the screen agrees with what you think in your mind. Okay, thanks.